this looks a little bit scary, right? So we're coming into functions, and we have this is where I talked about how we're going to introduce recursion, and how it is an advanced topic, and I was just throwing it in to see, who could pick up on it. Just this, it was like a test, right, to see if you could pick up on it. But it does sound like you do you have a familiarity with recursion at all?
Yes.
Okay. So this probably isn't a big deal for you. But anyway, so I'll try to go over this slowly just for everyone else who watches this later and doesn't know what's going on. But basically, like, disclaimer, like, you don't need to know how this works. This is an advanced topic, and yeah, I don't know. Like, this is for the hardcore guys. But anyway, what's happening here is that recursion just means you have a function that calls itself. So how you write a function definition is just you just do def. Sorry. Okay, you do def fact. I named it fact because we're just doing factorial. So for those who don't know what factorial is you have like 5 factorial is equal to 5 times 4 times 3 times 2 times 1. That's what factorial looks like. And if I know my factorials, that should be 120, right? 20, 60, yeah, 120. Okay. So that's what factorial is doing. And so the idea here is that, you have the definition and you have the function name, and then you generally need the brackets, and you put your arguments in the brackets. So like for me, you can have functions without arguments, and but for me, and you can have functions with multiple arguments. But to keep it easy, we just have this factorial just needs one argument, which is just the number that you're trying to take the factorial of. So for example, you would just do like down here I have factorial 5. That's exactly evaluating this right here, 5 factorial, which is this number. And how we're achieving that, okay, so in recursion, you need basically, let's look at the return statement first. So what is the return statement doing? So the return statement is giving us a value, okay? And it can be whatever. You can even return nothing and just like print a string if you want to. In this case, factorial returns an integer value, and it usually takes positive integer values as well. And if you notice, this actually isn't defined for 0. So actually 0, if you put in 0 here, you'd actually like break my code. But let's not worry about that. Just use like integers positive integers. Okay, so. So what's going on here? So we're returning n, and we're saying multiply n by factorial n minus 1, okay? So that is going to basically freeze frame what's going on, and it's going to call this function again. So it's kind of like a loop, basically. It's like a recursive loop. So this is going to call, so we're doing print factorial 5, right? So this is going to return 5 times and then whatever factorial of n minus 1 is. So 5 minus 1 is 4. So we're going to go back here. We're going to do factorial of 4. And basically, it's not 1, right? So just skip this. Don't worry about that for right now. And it's going to do return, and now our n is 4. So it's going to do return 4 times factorial of n minus 1, which will be 3. And basically what happens is this n gets saved from that other freeze frame that we had. So we already have 5 times, and now we have 4 times, and then we're going to do factorial of 3, because 4 minus 1 is going to be 3. So we put in 3, it's not 1, and then we're going to turn 3 times 2, and so on, okay? And we're going to get to, after we do 2, so return 2 times factorial of 1. 2 minus 1 is 1. Factorial of 1, if n is equal to 1, return 1. And then as soon as we have this, we can like re-roll our freeze frames. So then we're going to go back to 1 times 2 times when we had the 3 times the 4 times the 5. And it's going to give us this. Maybe it's worth pulling up Paint real quick as well. 1 second here. So, okay. So here we go. So let's say we have, I don't know, whatever. We have 5 times factorial of, 5 minus 1. Okay? Now this 5 minus 1 is going to come out here, and it's going to do, like we said, it's 4 times factorial of 4 minus 1. Okay? And basically, it's just going to repeat. So if I can zoom in here a little bit. All right, this is a little bit tricky. Okay, so let's compress this. Okay, so this becomes this, and so now we have our whole thing should be 5 times 4 times factorial, and if we just simplify 4 minus 1, we will just have 3. Okay. And where's my eraser? How do I make my eraser bigger? Let's go back to the brush. So now, okay, factorial 3, basically the idea is that it's going to evaluate again to 3 times factorial of 2. I think it looks pretty clear now, right? So this becomes this gets crossed out, and then we can just actually do new, and then we have 5 times 4 times 3 times factorial of 2, and then that becomes this becomes 2 times factorial of 1. Okay, here we are. And then factorial of 1, if we go back here, if n is equal to 1, it returns 1, right? So this becomes 1. And then now we just have, like we said, now this just becomes 5 factorial. Okay. So, yeah. I mean, like I said, yeah, that was, a bit advanced, but, I don't know, for the enthusiasts or for people who want something to think about. I feel like the lecture's been pretty light until that, so people who want to learn more of that stuff, you can kind of study this, work through this. The idea behind any recursive function, though, is that you have like this return statement, and then you want to decrease the size basically of your recursive call. So you're always moving to you're basically taking a big problem, which is 5 factorial, and you're breaking it down into smaller problems, and you want to land into a base case. And in our case, the base case is 1. And really, if we wanted to be a little bit safer, like I said before, like we can do something like that. Then you can type in like 0 and you should get 1, and so on. And I'm not sure if factorial is even defined for negative numbers, but if you put those in, now our function will just give us 1, because any negative number will also be less than or equal to 1. So there we go. Okay. What do you think? Brian? Do you have any questions about that, or any way to make that clearer?
No, that was pretty clear.
Okay. But anyway, okay. So then now, this is for people who didn't understand that previous example, and we have the non-recursive version of the factorial, which is just like iterative. So you basically just have, see, now it becomes, like the code becomes a little bit like more complicated, but it's really, we're just avoiding recursion and so on. And, like what we talked about here, this could probably be a for loop, but I just made it a while loop just because, I don't know, I really just felt like it, I guess. You have to start out with I used this temporary variable to store the sum. This is what we're going to end up returning in the end. But, so basically while our n, which is going to be our argument, which is going to be 5, while that's greater than 1, you have the sum, you multiply the sum by the number, right? So you have like, at first, you start with 1 just because 1 times anything is that number. And then you can continue that way. So now you have the number and you're multiplying by the new number. And the new number is going to be the n, which is going to be subtracted by 1. So this is going to go through. So say we call 5. We have 5 here. Sum is 1. And n is going to be 5 right now. And that is greater than or equal to 1. So now the sum is going to be 1 times 5. And then n is going to be 4. And then we loop. So remember, sum was 5. And now 5 is, or this is 4 now, so 4 is greater than 1, and then sum is 5 times 4. Subtract and go through, and it's n is 3, and so 3 is greater than 1, and you know, we had 5 times 4 here before, so now we have 5 times 4 times 3, and then n becomes 2, and this is still valid, this is still true, we still go in here, so 5 times 4 times 3 times 2, and then subtract 1 again, and then, 1 is greater than or equal to 1, so one last time. And this part even isn't really necessary. I guess you could just do while n is greater than or equal to 2, actually, because you don't need to multiply the 1 again. So we're multiplying the 1 here. So we have 5 times 3 times 2 times 1, and yeah, that's the factorial, and then now our n gets subtracted by 1 and becomes 0, because it was 1 before, and that is not greater than or equal to 1. So then you return sum, which is what we wanted to do. So after that, we skip everything that's indented, and we just get to the return statement. Also note that we don't hit this line while this is true, right? Because we're just doing this part. We're just looping in here in this indented stuff, and then at the very end, once we're out of the loop, we hit this return statement. So yeah, I mean, that might be a little bit more complicated to think about, but anyway, that's how you do it non-recursively. Hopefully that makes sense. All right. So, okay. What do we think? Are we ready? Are we ready for strings? You have any more questions about functions?
I actually struggled a little bit with that one. Can we go back up just a sec?
Yes. Yeah. Okay. It was a little bit more difficult, right? With the non-recursive method. Okay, so what was tricky, I guess. One thing I swept under the rug was, I'll just mention this, was that I had to declare this up here just because there's something called like variable scope, and I would not be able to return the sum if it was only in here, because it basically gets like deleted. It's like a local variable, and inside this loop it would have been deleted once we got out of the loop. So I had to declare the sum outside of the loop. But yeah, what was tricky about this one?
Yeah. So I actually got that, but that was really eloquently put, so that was good. Actually thinking about it now, I get it.
Yeah, it's a little bit not as clean with the while loop. Like, let me think. Let's think about this. Maybe I can do this on the spot. If I have like fact n4 or whatever, and we want to write this in a for loop, let's see, for x in range of n, it's gonna go from 0 up to, we want to start with 1, and we actually want to do n. Let's just see if this looks any better. For x in range blah blah blah, yeah, I think we still would need a sum because we're not storing it any other way, so we still need sum is equal to 1. And then we need to do sum is equal to sum times x. Oh wait, did I say minus 1? Okay. And then we return sum. Yeah. That one looks a little bit nicer, right?
Yeah, I like that.
Okay. Let's just make sure that one works. Make sure both of these work. So we should get 2 120s as long as I don't have anything else. Yeah. Well, let's see what Python says about that. Yeah, okay, great. 2 120s. Okay. So yeah, I mean, yeah, like I said, whichever is your preference. Yeah, this is probably nicer. What this is 4 lines, and this is 5 lines. So yeah. Yeah. Yeah, it looks probably looks nicer with the 4. So That's good. We can include that in
Yeah,
there as well.
Yeah, so I get the while now. I had to think about it for a second. You definitely have to set sum equal to 1 outside of the while loop.
Yeah.
And then you have to set sum equals sum times n because, the for a while loop, if sum doesn't change, you're going to be stuck in the while loop forever.
Yeah, if the n doesn't change. Yeah, exactly. Yeah.
And then n has to change as well. Yeah, so it took me a second, but I just had to think through it a little bit.
Well, it's just the sum is fine. The sum is just like to make sure our result is correct. We wouldn't stay in the while because the while is dependent only on n, right? So it's only the n you have to change to get out of the while loop. We could do something weird with the sum that didn't really work, and as long as we subtracted n, we would still get out of the while. Yeah.
Oh, you're totally right.
Yeah. It's just the n.
While loop depended upon the n and not the sum. Okay.
Yeah. Yeah, I mean, yeah, if you're probably not used to while as much, because it sounds like you didn't use it too much, but yeah. While is weird. You have to be a little bit careful with this. Yeah, that happens all the time. You get an infinite while loops. But sometimes you want to be in infinite while loops, and like I said, we will get to that.